Welcome to qnawire.
So we place a single circular loop of wire that has area A1 inside a long solenoid, and is situated such that the plane perpendicular to the axis of the solenoid is exactly aligned with the area vector of this small loop. And we are told also that the current flowing through the solenoid is given by some constant value, I0, times the cosine of omega t. So this is a time-dependent current running through the solenoid. We're asked to find the induced EMF in this small loop. The first thing that we should calculate is the magnetic field of the solenoid. And since we're told this is a long solenoid, we can simply approximate this as mu naught times n, the number of turns per unit length, times the current running through the solenoid, which in our case is I0 cosine of omega t. Therefore, the flux through A1, the magnetic flux through A1, is simply the area of A1 times the B field, which has a value of mu naught n, I0 cosine of omega t. From here, we can find the induced EMF by simply taking the time derivative of the magnetic flux, where this is the magnetic flux through A1. So now we can see the only time-dependent component is this cosine here. When we take the time derivative of cosine, we end up with a negative sign, but noting that we also already have a negative sign out in front of the time derivative, the two negative signs cancel, leaving A1 mu naught n I0 sine of omega t. And this is our final answer.